We are continuing the concept of similar figures. You will notice, what do you notice on the whole page, problem solving skills? When you look at something, you're like, oh, this is a pattern. What do you notice on this whole paper? Do what? No, wrong is. Wrong is not it. So, triangle. The entire, that's exactly the answer. The entire paper is triangle. You notice that? And if you look at the last paper we did, maybe, well, I have the last paper we did, it's the packet. But on that one, what was it say? Do you remember? 62 similar polygons. You might remember the same. Not one right answer. There's triangles, there's squares, there's rectangles, there's octagons, hexagons, pentagons. So basically, any shape, right? And now we're looking at the triangle. We're getting to a shortcut with triangles. That'll be tomorrow's lesson. Today, what I want to do is show you that if you have two triangles, what do you notice? Yeah, I was going to say what you notice all of them. One beautiful city. Beautiful, but not. You notice the majority of these triangles are touching each other? Like they share a side. You notice that? This whole paper is committed to just talking about when the triangles either share a side or they have a certain layout. They're not touching, but there's a certain layout here, and that's how we set it up. So let's just start right in at the beginning. Parts of similar triangles. There's three scenarios. This one's called an alpha, an angle bisector, or a median. You might look at the pictures and think, well, they all look the same, but there are differences in all of them. Look at the top, the altitude triangle. What's in there that's not in the other four? 90-degree angle. And that's exactly what an altitude is. And what do you, can you tell me in the real world where you've heard altitude before? Yes. Like if you're, what? If you're on a plane, the pilot will always say we've reached the cruising altitude of 32,000 feet, which is not what you want to hear if you're afraid of heights, right? If you are skydiving, I jumped out of the plane at 11,000 feet. So the altitude of how high I was above from like sea level was 11,000, and when I jumped out of the first seat of the airplane, there was a guy that back of me who pulled the third seat. I made it. That video is on my YouTube channel. It was great. It was great. I highly recommend it if you've ever been anyways, okay, so an altitude in terms of the triangle is, take your pencil, or if you have a color pen or a highlighter, is that line that's dropping straight down. I'm actually going to do a highlighter, and I can bring you one more. It's that line that's dropping straight down, perpendicular to the bottom of the triangle. Highlighter, English. So these are altitudes. They're dropping perpendicular to the bottom. When you have a triangle that has an altitude, the altitude, because it's perpendicular to the bottom, is actually cutting that really big triangle into two similar triangles every time. Okay? Now there's multiple ways to set it up, but I'm going to give you the one way. It doesn't hurt. I'm sorry, it's not helpful to show you all the ways when there's like 8 of them. Like 8 different ways. That would just overload you. It's too many choices. So I'm just going to give you one method. Here it is. We're going to set up a proportion fraction equals a fraction. Watch what I compared. BB, which is the altitude, compared to the altitude of the other triangle, so SA, as, now this next fraction could be anything. I'm just going to pick AB right there. That is kind of alphabetical. And the triangles are turned the same way. AB compared to EF. So that's one of the possible 8 different fractions set up. You definitely want to pull in there the altitude. Now, this whole fraction here is the altitude. And then this is the two sides that correspond. All right, now, angle bisector. Remember what bisector? Cut in half. Very good. Did you notice how this segment QS, it shows that this is congruent to this? And then this is really kind of, somebody's going to draw it out here. That's congruent to that. That QS and UW are angle bisectors. They're cutting those angles in half. So let's create a proportion that can work here. Once again, you're going to, first fraction, definitely going to pull in that angle bisector. So that would be QS compared to UW. The next fraction could be multiple things. I just run with like the left of the triangle. You see? So 2 things on the outside on the left, and 2 things facing the same way. And you cross off our salt. Notice though that the first fraction is once again the line segment is cutting right through the triangle, right? And then the second fraction is one of the outer edges. All right, median, when you're driving, what's the median? It's the, usually has grass in it sometimes, portion in the middle of the road, right? You don't want to go for the median. Not a good driver. But the median is separating you and the other direction of traffic. Okay, in terms of the triangle, a median is in the middle, right? Coming segment that comes from the corner of the triangle to the other end, and it's cutting the other end in half. So it's in the middle. Think of it of that road. So like over here, and this would be correct. All right, let's set up a fraction equals a fraction, proportion. First fraction is going to pull the segment that's running right through the middle of the triangle. So you've got HJ compares to LN. Second fraction, lots of first choices here. I just ran with the left side of the triangle here. Runs with LK. Again, there's like 8 different ways to set it up. Your mind, when you start doing it in different ways, it's going to come to the right answer. That's okay. All right, I'm just giving you something to go by if your mind can't see it at all. You just go by the formula. Notice the formula again. The first fraction on all of them came from what was running through the middle of the triangle. Like the big triangle, it was running through the middle. And then the second fraction came from just comparing 2 outer edges that you know correspond. Okay? All right. Yes. Yes. Yeah. Yeah, because you're not really writing letters in down here. You're just pulling it in. Yeah, this is just me giving you, we don't have any measurements here. All right, let's dive into number one. It'd be good if you could start recognizing, am I dealing with an altitude, an angle bisector, or a median? Because that kind of reinforces the stuff we've learned along the way. So like number one, are the altitude, median, or angle bisectors? These are medians. I'd love to see you write like right here, your problem. Now, there's a lot of information in here. There's more information than there's in here. We only have values, right? But we've got way more than four. What is one value we absolutely have to put in our fraction? All four of the fractions. What's something that has to go in a fraction in order for me to do what it's asking? X. So you may want to direct your attention to where's X first. So you've got to get X in there. It says solve for X. X is right here, which is the segment cutting through the middle. So X compares to what from the other one? It's going to be the segment cutting through the middle, 15. X compares to 15 as, and now you have the freedom of choice of what you want to use for your other fractions. Be careful, these triangles are not turned in the same way. So here's what I like to do. When I've got too much info and they're not turned the same way, I like to use the letter S for small and L for large to let me know is this triangle like 16 and 19.2. 16 is the small number, 19.2 is the bigger number, right? I like to come over here and do the same thing. And then that way I'm comparing the correct sides together. That's one way to do it. Coming over here, I got 20 and 24. 20 for small, 20 for large. Now I just pick two, small or too large. Does not matter as long as you're consistent. There's a pattern here. X came from the left triangle. So over here, my top number needs to come from the left triangle. What do you want to do? You want to do small or large? You want to do small since you go to decimal? Okay. All right, so it's 16. And then come over here with one small. With the 20. And now you cross multiply it all. Will you be here tomorrow, or you leave after about the same time tomorrow?
No, we leave that. Don't do that.
Oh, okay. This video is on the 14-minute mark. If you want to get the rest of the notes, fast forward to 14 minutes, and then look for the two questions. Just with my fingers. Okay. All night long. Yeah, it is. I go over here just for that. Oh, yeah, that's true. You already have a free receipt, right? You're welcome. No, you're good. Are you yeah. What'd you get when you crossed both lines? Two, zero. Did you get 12? The whole small, large label is what I like to do. I don't like to use the letters, but let's say you like to use the letters. Small, large. Look what they gave you here. They give you a similarity statement, which means when you go to get your second fraction, just pick one of the numbers. Let's say you decided to take decimal. You would come over here and say, what side is ST? So then you come up here and look. ST is the first two letters. So over here I choose DE, and that is how you know to pick DE. So you can either do the whole small, large label, or you can just read the letters. Okay? But either way works. I like small, large, I like large. All right. Let's do number 2. First of all, what type of problem? What type of problem is number 2? It's an altitude problem. It doesn't really matter what type of problem it is. I just wanted to practice with those vocab words. Altitude problem. So, again, we're going to find x first and make sure that goes in your fraction. X is right here as HI. So we'll start with X. X is HI. We're going to come up here and find HI. It's the last two, which means it corresponds with LK. Now I'm going to go over here and find LK. LK measures 14. Then my next fraction needs to be just numbers, and in this case, they only give you what you need. There's no extra info, right? So the next fraction would be what number? 10. Keep it consistent to 8. And then you cross multiply. 8x equals 140. X equals 17.5. All right, number 3. What type of problem? Angle bisect. I'm just going to write it like this. An angle bisect problem. We're going to set up fraction equals fraction. I'm going to start with X. I'm going to find it right here. F. So F means I'm going to get AC. What's AC? 38. Then my next fraction will be just the number. In this case, again, there's no extra info. No left. But be consistent. X came from the one on the right. So this top number has to come from the one on the right. So it'd be 24 over 36. Cross multiply and solve. Let's see if we get 28.5. All right, number 4. What type of problem is it? So it looks different than all of the others. But what is the like? Simple in it to let me know what problem it is. Not altitude. Altitude. This is an altitude. What it's doing is it's showing you that you have what's called an obtuse triangle. You can't necessarily draw a straight line with perpendicular to the side of the triangle. When you draw a straight line perpendicular, it actually ends up kind of coming out here on the outside of the triangle. And that's okay. They're just it's giving you basically the height of the triangle, but measured over here because the triangle's opened up wide. But everything's the same. Okay? So fractions for fractions. I'm going to pull x first. It's not on me. So I have to make sure I've got x in my fraction. X is coming from side QT. QT is the first two letters. So I need to use TU from the other one. So x compares to 42. And now come back. And then we're using those altitudes. 12 over 16. Very good. You do get a decimal. You just put around here. 12 multiply next to you get it 33.6. All right. On the back, I'm going to leave number 5 for you to try. What's going to happen is you're going to, oh no, we're going to skip 5. We'll come back to 5 tomorrow. 5's going to have a quadratic and you may not remember how to do it. So I'll walk you through 5, okay? This is your homework. Go down to where it says triangle, angle, bisector, 0. Notice the picture looks the same as one of the ones on the front. But this time there's just one line instead of two. This is still an angle bisector. The difference here is, look at all of these examples. You notice that the only info we have is where from the outside. They don't give us a single info on that actual bisector. So this is what if all we have is on the outside? You can still set up a proportion. Multiple ways to set it up, as long as it's consistent. Here's one way that works, in case your mind doesn't see the multiple ways. Basically, you say to yourself, well, when AG down here is opposite of that 0 angle compared to CD, so I just trace those edges of the two triangles. Now I'm going to trace the other edge of the two triangles. Stay on the edges, right? So like as AB compares to CD. So you're basically tracing, you're saying, okay, this edge compares to that edge, and this edge compares to that edge. And you end up using just the edges. You don't use the line in the middle. Now, y'all know me, I like to start with that. We don't have to use it because we're going to put on the edges of the race so that's the people think that. Some people like to jump from one to the other, one to the other. Some people like to say, well, I'll say that first. Let's jump from one to the other. So X is down here. They're saying KM represents the angle bisector in like 5 seconds. So X is here, it's in here is 4.8. Think of it as the side opposite of those two known angles. Now, X takes me one over here, so 18 goes to 12. Multiple times 12, you can get 7.2. Right, look and see if you can get that. And then I'm going to show you something that you may like better. Only when it's used I'm gonna put, also, dot, 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 dot. I'm copying the exact info from that problem, because I want you to see that this other technique works, and some people like this technique better than jumping from triangle to triangle. Here's the technique. The idea is these triangles are similar, right? Which means that it's the same proportion all around. Some people prefer to say from one triangle, so like X is to 18, because those are in the same triangle. Now, these are consistent. The X came from the bottom, 18 was the edge. So over here, the 4 point in here is 12. And then if you cross multiply that, you're going to notice that you don't get the exact same answer, which is no jumping from triangle to triangle. Instead, you're basically comparing two to two. Some people like that method. That's the method where I'm on it. It doesn't matter, you're going to get the same answer, okay? Some of you, I'm noticing when you took off the